Okay, so let's have a look at number 4 now. It says figure 1 shows a sketch of the part of the curved equation given to us. We can see the finite region shaded in, and we know the upper limit and the lower limit. It says copy and complete the table with the value of y corresponding to x equals 3, giving your answer to 4 decimal places. Right, okay, so y equals, in that case, you know your x equals 3. So let's actually just write the formula out. So when x equals 3, y is going to equal 3 plus 1, 3 over 1 plus root 3, which we are going to work out to some number of decimal places here, 4 decimal places, so 1.0981. So there we have the answer to part A. Now, part B, it says use the trapezium rule with all the values of y in the completed table to find an estimate. Now, that region R is going to be approximately, we should remember the formula, it was h over 2 times by y0 plus yn plus 2 times by the middle values, which were y1 all the way up to yn minus 1. Now in this case, your h is the gap between your x values. So in this case, your h is 1. Your y0 is your first y value, 0.5. Oops. Your yn is 1.3333, and your middle values are 0.8284, and we had 1.0981. Now the biggest area where students make mistake here is to plugging it in the calculator. So just take your time ensuring that you do this correctly. So 0.5 multiplied by open brackets 0.5 plus 1.3333 plus 2 times by open another set of brackets. Let's just change that to a times in there. 0.8284 plus 1.0981. Close brackets and then close another set of brackets. And we get 2.843 to 3 decimal places. So we've got an estimate now because we've used a numerical method to work out the area. But in part C, we have been asked to use substitution to work out the exact area of R. So let's have a look at that. Your upper limit was x equals 4, your lower limit was x equals 1. Your integral was x over 1 plus root x dx. So this should give us the exact area. Now, we've been told to use the substitution, which makes our life a little bit simpler. Okay, so u equals 1 plus root x. 1 Now, 3 things you need to remember. Change your x's to your substitution dx to du, and your x limits to u limits in this case. So let's start sort of working through this. 1 plus root x is u, so this becomes u. I've got dx here. Your limits haven't changed, so they remain at 1 and 4 in terms of x. Now, if I think about it, u minus 1 equals root x. So x is going to become, to get from here to here, we're going to have to square. So we are going to square both sides. So now we've got u minus 1 squared replaces x over u dx. Limits haven't changed in terms of x yet, and dx hasn't changed in terms of u. So if I now differentiate, I get du over dx. When I differentiate 1, that disappears. When I differentiate x to the power of a half, I'm going to get a half times by x to the power of minus a half, which is 1 over 2 root x. Now, I'm trying to make dx a subject because I need to replace that, but at the same time, it is worth noting that root x is u minus 1. So I'm going to say 2 root x du equals dx. I'll multiply this to the numerator, but I'm going to replace x in terms of u minus 1. So I get 2 times by u minus 1 du equals dx. So here we get u minus 1 squared over u. Dx is going to become 2 times by u minus 1. And we've got a dx here. We still haven't changed our limits in terms of u. We're going to do that shortly. So simplifying this, we get u minus 1 cubed. We've got 2 at the front. And actually what I'd like to, because it's a constant multiplied at the top, we're going to take it outside. We've got over u du. I made a little mistake. This should be du here. Right, okay, not straightforward here. So now let's work out our u limits. So u equals 1 plus root x, so 1 plus root 4. So we get 3. And u equals 1 plus root 1, which is 1, so we get 2. So we're getting closer. U equals 3, u equals 2. Got 2 outside, u minus 1 cubed over u du. Right, okay. Now, what is my thought process here? I can quite easily do the expansion of u minus 1. Here, u minus 1 cubed. So there's no, it's not really difficult. It's not too big a power. So I'm going to go ahead and do that. In fact, I remember all the coefficients. So we're going to get u squared. We've got 3u squared. We've got 3u and then we've got -1 here. Okay, now I just want to make sure that I get the signs right. So this has been multiplied by -1. So this is -1 squared is positive, and your last term was -1 cubed, which is -1. And this is all over u du. The limits are u equals 3 and u equals 2. So what are we going to do here? We're going to, because we've got all of these terms divided by u, it's best to simplify. So u squared minus 3u plus 3 minus 1 over u. And du, your limits are u equals 3 and u equals 2. And we can now integrate. So we get u cubed over 3 minus 3 over 2u squared plus 3u minus ln u, and your limits are 3 and 2. Well, I substitute 3 in there. 3 cubed 27 over 3 is 9. What do I get here? 3 times by 3 squared is 27 over 2 plus 9 minus ln 3. And then if I substitute 2 in there, 2 cubed is 8. So we've got 8 over 3, take away 1.5 times 4 is 6, plus 3 times 2 is 6 minus ln 2. So once I've done this, then I think it's probably best to put it in the calculator. And actually I'm going to go ahead and work that out. But I do like doing this step without the calculator, because otherwise it can become fiddly trying to type all the powers and things in there. So we've got 2 open brackets, 9 minus 27 over 2 plus 9 minus, well, we need the exact area, so I'm going to leave the ln 3 for the time being, minus 8 over 3, and that is it for the numbers. Okay, so let's have a look at that. So we have got, for our rational numbers, 11 over 3, because I multiplied 2 in. Now 2 times by that gives us minus 2 ln 3. And then I've got a minus and a minus is a plus ln 2. So we get plus 2 ln 2. And so if I want to simplify this, we get 11 over 3 plus 2 ln 2 over 3. And there is our exact value. And we can check. It should be quite similar to our answer to oops, where are we? 2.843. So let's actually work that out and get a reasonableness check. So 11 over 3, let's close 2 brackets, plus 2 ln 2 over 3. And so we see that it's actually not too far off. So this gives me confidence I've worked out something correctly, hopefully.